So today we will be learning about smart materials, or we're going to start the topic smart materials, and then next week we will be moving on to the next part of smart materials. So this is just us finally finishing materials in general. So we've already done wood, metal and plastic, and now we're moving on to the final one, which is smart materials. And there's only two different types of materials in this. So it's not a long topic, but it is a wee bit more complicated than the other materials that we have been learning about. So smart materials. Obviously we were learning about wood, metal, plastic, and they would be the main ones that you would use for building and construction based on their physical properties. However, imagine materials that could transform their properties from one state to another. Well, we don't have to, because they're known as their smart materials. So you could do transparent into opaque, malleable, which means it's easily bent or stretched into wires, and then into rigid or durable to biodegradable, which is what a lot of people are looking at the minute for making plastics, how we can cut down our plastic use and stuff, and how we can make plastics less durable, and how to make them more biodegradable. So smart materials. Smart materials are a new and growing area of technology where materials are designed to solve new and old problems. So they take old problems and they're introducing these smart materials, or these stimuli, to make a more efficient solution. So as I said, for plastics, making them more recyclable, or how we can biodegrade them without recycling, and things like that. So smart materials provide new opportunities for design and innovation. Smart materials are, and this is the most important slide that you will need. So if you take anything from this PowerPoint, this is the most important slide here. So smart materials are materials that are designed and manufactured to contain special properties. So when I say special properties, I mean changing properties, and they will always go back to their original state. So it's materials that can change from one state to another, and the changes are activated by environmental. So that's like heat, moisture, wind, things like that, or direct stimuli or stimulus. So that is then adding electricity, or putting direct heat on that is not from the environment. And your stimuli are the thing that will make it change, and the thing that will make it change back to its original state. So the stimuli can include temperature, moisture, electrical, magnetic, pH, so that is then the chemical buildup, or stress conditions, and light. So if you take anything, make sure you know them stimuli there, especially temperature, light and pH, because they're the ones we're going to be looking at the most. Oh, and moisture as well, because with self-cleaning glass you'll need the moisture. So the two ones we're going to be learning about, the two common smart materials, are thermochromic pigments and self-cleaning glass. And today we're going to be learning about thermochromic pigments. So this here is your thermochromic pigment, and it is changed by heat. So thermochromic pigments are liquid crystals. So it's crystals that are liquid. So no way to describe them. They're not a physical strong, they're not like diamond or any mineral that we have. They are liquid, but they're still called crystals, that change colour when temperature changes. They can be designed and manufactured to change to one colour specifically, so you can go from like white to grey to black, or it can change to different colours depending on the range of temperatures. So it can go straight from white to black, or it can go a range of different colours, and you can make it whatever colour you want. As you can see, I've added a wee photo here of a colour changing mug. That is thermochromic pigment. So it goes from black, you put the heat onto it, and it turns white. So thermochromic crystals can be added to pigments, paints, inks, and they're used in variety of applications. So I think this wee video just shows that the black can go to actually clear, so you'll be able to see through these sheets. As you can see, the heat's being added and you can see through it then, and then that its most common use is actually for like blinds and stuff, and when it heats up during the day, because obviously it's very cold at night, it'll go black and it'll become opaque, and then obviously go clear in hotter temperatures. So thermochromic pigment. One application for thermochromic pigment is for temperature gauge or thermometers. So as you know, you can stick your thermometer in your ear, and they always have more high-tech ones in the hospital, but I remember when I was younger we used to get these contact ones, these contact thermometers, and you put them on your child's head and the colour will light up at a specific one. So as you can see here, it is up at 39 degrees, so you can tell that this child has a temperature of 39 degrees, which is high. The thermochromic pigments are designed so that each temperature is represented by a different colour, and as you can see here, each bar, so it knows that at 39 degrees it needs to be changing colour. These can be used for testing body temperatures, or it can be used in fridges and freezers, especially in industry, and it makes it easy. They can just go open the fridge and they can say, oh, that fridge is too hot, we need to change the temperature, that sort of thing. And it's so you're not reading wee small numbers and you're not reading different things and making it overly complicated. The bright coloured pigments are easy to read at each temperature, as you can see here. This excludes the need for reading small set markings as required in traditional thermometer. It makes it easy for people to read, and it makes it easy for people to read all over the world. As you can see here, this is in Fahrenheit and this is in degrees C. Fahrenheit is obviously used by Americans, and degrees C is obviously used in Europe. So, also, as well as thermometers, the indicator strips on batteries, so you can get these special batteries, usually the Duracell ones, and it shows the level of electricity remaining in the battery. Basically what is happening here, it's a clever use of thermochromic ink. So you place your fingers on these two white dots, so you won't get electrocuted by putting your fingers on the positive and negative side of the battery, but you still get a reading. So you place your two fingers on the white dots and it makes a complete circuit basically, and then the resistance strip of thermochromic ink tells you here. So as you can see, red obviously means 100%, but that will go down and down and down depending on how much energy is left in the battery. So basically thermochromic film heats up based on your based on your body temperature and you stimulating the circuit. Another common example of the use of thermochromic pigments is on novelty mugs. As I said at the start, it's your thermochromic paint, and basically it's just a layer over it, and you can't put these mugs and stuff in the washing machine and the microwave because the layer of thermochromic pigment will come off due to the amount of heat that's being added to it. So when a hot liquid such as coffee is poured into the mug, thermochromic paint on the outside is stimulated by the heat changes. Another good example is mood rings. So if you've ever had a mood ring, and you know they change colour, and of course it's supposed to tell your mood. However, it's not. It's actually the science behind it is it's thermochromic pigment inside, and when your body temperature changes, the colour changes. And yep, that's the end. I would like you today to read through this, make notes in your book. There is a booklet here I'm going to give to you. Do not read on past thermochromic ink because we are going to move on to self-clean gas next week, and I would like you to complete the past paper questions that I'm also going to upload. Like I said last week, or as always, you can ask me a question. I will upload more videos. If you need help on the content of these lessons, if you need more past paper questions, if you would like more past paper questions, I will upload them for you as well. Just contact me through Google Classroom, through email, and I will try and get that sorted for you. If you have any questions, please do not hesitate to contact me. Thanks very much.